Algebra 2 Honors Lesson 5.4 Factoring Difference of Squares and Quadratics in the form ax squared plus bx plus c. Alright, here are the lesson's objectives and the vocabulary for the word greatest common factor. Now let's say we have a factoring problem. Alright, let's say I ask you to factor x squared minus 6x plus 8. Right? If it has three terms, right, this is considered a quadratic, right, in the form ax squared plus bx plus c. In this case, right, our a value would be this imaginary 1 right here, that would be a, the negative 6 would be b, and the c value would be 8. Now to factor this, what we're going to use is the x, right, what I call the x method. Now to get this number right here, alright, you multiply a times c, or the first number times the last number. So this would give us 8. To get this number here, it's the middle number, it's b. It's whatever b is. So b in this case is negative 6. Right? Now you want to think, what two numbers multiply to give you 8 and combine, add up to give you negative 6? Well, that would be negative 2 and negative 4. And let's check. Negative 2 times negative 4 gives you positive 8. Negative 2 plus negative 4 gives you negative 6. So that's correct. Okay. Then you want to divide by the a value. The a value in this problem is 1. So we're dividing by 1. Okay. See if you could reduce these fractions. If you can't reduce, alright, that's fine. So once you have these fractions, you would go straight to your factors. Our factors would be, now the denominator is the coefficient of x. So if this is 1, this is going to be 1x, then minus 2, right, whatever the numerator is. And over here you have 1, so that'll be 1x, then minus 4, so that'll be minus 4 right afterwards. Okay. Now you don't really have to put the 1s, I'm just putting them there right now so that you understand that the numbers on the bottom here in the denominator go in front of the x. Okay? Let's try another one. Let's say we need to factor x squared minus 11x plus 24. Okay. Now the first step in factoring, right? The first step in factoring is to look for the GCF. Alright, you always look for the GCF first. Okay, so we look to see, can we take anything out? Is there a greatest common factor for these three terms? No, there isn't. Okay, so then you move on to the next step, which is trying to factor it. So if it's got three terms, we're going to use the x method. Alright, pretend there's a 1 here. This is our a value, our b value, our c value. So remember, to get this number, you take the first number times the last number, or a times c. That would give us 24 in this case. Alright, b is negative 11. So we'll multiply to give us 24 and adds up or combines to give us negative 11, or negative 8 and negative 3. Okay, and it doesn't really matter the order, alright, that you put. If you had negative 3 here and negative 8 here, that's still okay. Just double check to make sure. If you multiply these two, do you get positive 24? Yes. If you combine them, do you get negative 11? Yes. Now we need to divide by our a value. Our a value in this case is 1, so we're dividing by 1. Can you reduce the fractions? Nope. So we go straight to your factors. So if you have 1 down here, basically that means that's 1x, or x, minus 8. And then you have a 1 right here, well, that means that's 1x, or x, minus 3. Alright, and then you're done. Okay? If you want to check to see if you factored correctly, what you're going to do is FOIL. You take the multiply these, right, that will give you x squared. Multiply these, that will give you negative 3x. Right, multiply these together, that will give you negative 8x. And multiply these, that will give you positive 24. Combine like terms, so you get x squared minus 11x plus 24. Okay, so if you FOIL the problem, right, it should give you, alright, the question. Alright, that tells you factored it correctly. Okay, if you factor a problem and then you FOIL it to check and you don't get the problem, then you've factored the problem incorrectly. Okay. All right. Let's say we need to factor 3x squared minus 16x minus 12. Okay, let's look for a GCF. So is there a GCF? All right, can we take anything out? No, it doesn't look like we can take anything out. Okay, so let's go to our x. All right, remember this is our A value, our B value, and our C value. To get the top number is A times C. So 3 times negative 12 gives you negative 36. Our B value is negative 16. So what multiplies to give us negative 36 and combines to give us negative 16? Well, that looks like negative 18, right, and positive 2. Let's double check. Do these multiply to give us negative 36? Yes, it does. Does it combine to give you a negative 16? Yep, it does. Now, what's our A value? Our A value is 3, so we're going to divide these numbers by 3. Reduce to fractions if you can. Alright, this one can't be reduced, but this one can. This reduces to negative 6 over 1. So let's go to our factors. So if we have a 1 here, that means it's going to be 1x minus 6. Over here you have 3, so that would be a 3x plus 2. Okay, once again, you don't really need to put the 1 here if you don't want to. I'm just putting the 1 there right now so that it's clear that the denominators go in front of the x. Okay, and if you want to do the check to see if you factored correctly, just FOIL this problem. Okay, remember foiling is like distributing twice. Okay. Alright, let's move on to the next problem. So we need to factor 3x squared minus 24x minus 27. Well, our first step, we look for a GCF. Alright, what's the GCF? Well, what can we take out from here? It looks like we could take out a 3. Alright, all 3 terms share a 3 in common. So if we take out a 3, we're going to end up with x squared minus 8x minus 9. Okay, so we've taken out the 3. Now what we're going to do is we're going to try and factor this now. So since it has 3 terms, we're going to use the x method. Alright, you pretend there's a 1 here. So that's our A value. This is our B value now. And this is our C value. Alright, to get this number here, it's A times C. So 1 times negative 9 is negative 9. To get our B value, alright, right here, it's our B value, this number. So it'll be negative 8. Alright, let's find our factors. Well, that looks like it's going to be negative 9 and positive 1. Do these multiply to give you negative 9? Yes. These combine or add to give you negative 8? Yes. What's our A value? Our A value is 1. So we're going to divide both of these numbers by 1. So this is going to give us 1x minus 9 and 1x plus 1 from this. Okay? Now, once again, you don't need to put the 1s from the x's. That's up to you. But don't forget, alright, remember we took out a GCF at the beginning, the 3? Alright, it has to be part of your answer. So it's just put the GCF right in front of these factors. Alright, so this would be the problem factored out completely. Okay? Alright. The next type of problem we're going to talk about, alright, are called difference. Alright, of squares. Now, difference of squares, alright, there are a few requirements, right, to be met in order for a problem to be a difference of squares. One, alright, there are 2 terms. 2, it has to be a minus sign. Alright, it must be a minus sign. And 3, alright, must be a minus sign in between the 2 terms. I'll make it a little bit more clear. And the last one, both terms are perfect squares. Okay. Now let me give you an example of a difference in squares. Let's say we have x squared minus 4. Now this type of problem is a difference of squares because it meets all three of these requirements. There are only two terms. There's a minus sign in between the two terms. And both of these terms are perfect squares. Now what do I mean by perfect squares? That means, alright, is there something squared that'll give you this? Yes, x. Is there something squared that will give you 4? Yes, 2. Alright, that's why these terms are considered perfect squares. Okay, so they're considered perfect squares. Right? So if there's something that can be squared to give you these terms, then these terms are considered perfect squares. So let's factor a few difference of squares problems. And there's a special pattern that we could use for factoring difference of squares. Let's say we have x squared minus 9. Okay? Now, first you have to recognize this is a difference of squares. Okay, it's a minus sign. There's two terms. Both of these are perfect squares. How do we know we're perfect square? They're perfect squares because x squared gives you this. 3 squared gives you this. So these are perfect squares. Now, once you figured out what these are, basically there's a special pattern for difference of squares. You're going to take these, alright, and you're going to have a x plus 3, and then you're going to have an x minus 3. Alright, so wherever these are, you're going to have a plus and a minus, and then just basically plug these in to both parentheses. Okay, let's try another one real quick. Say we have 4x squared minus 1. Alright, is this a difference of squares? Does it meet the requirements? Well, there are two terms. It's a minus sign. And is this a perfect square? Well, let's think. Doesn't 2x squared give us this? Right? And 1 squared gives us this. So yes, it's a difference of squares. So basically, you're going to set up your parentheses. One will be a plus, one will be a minus. It doesn't matter the order of the plus or the minus. Then take these, alright, and just plug them into parentheses. And that's it. Okay. Now, let's try another one real quick. Let's say we have 4x squared minus 9. Okay, is this a difference of squares? Let's check. Well, we know 2x squared gives us this. We know 3 squared gives us this. And it's a minus sign in the middle. So it is a difference of squares problem. So when we set them up, remember we're going to have a plus and a minus. Then take these numbers, right, and just throw them inside the parentheses. Plug them in. And then you're done. Okay? Now let's think. Let's say you forget the pattern for difference of squares. Right? If you ever forget this pattern for a difference of squares, you can always use the x to factor a difference of squares also. Let me show you. So let's say we use the x and we're factoring this problem right here. Alright? 4 is in front of x squared, so we know this is the a value. This is the a value right now. This negative 9, right, this is actually the c value and not the b value. We don't have a b value because there's nothing in the middle, alright, in front of the x, so the b value is actually 0. Okay? So if we're taking a times c, remember to get this number, we take a times c, so 4 times negative 9, that would give us negative 36. And we're trying to get 0 because our b value is 0. Right? So what would our factors be? Well, our factors would be, I believe, 6 and negative 6. These multiply to give you negative 36. And they combine to give you 0. Right? Our a value is 4, so we're going to have to divide these by 4. So then it's going to reduce down to 3 over 2. Right? And negative 3 over 2. So our factors in this case would be 2x plus 3 and 2x minus 3. You notice we get the same answer, right, using the x method. Okay? So if you ever forget the pattern for difference of squares, just use the x. Alright? If you do it correctly, it will also give you the correct answer. Okay? Alright, let's try factoring a slightly more advanced problem. say we have 9x squared minus 36. Now once again, you have to remember the first step in factoring, alright, is to look for a GCF. Alright, that's very important. Okay, if you don't take out the GCF, alright, you're bound to make a mistake and the problem won't be factored out correctly. So is there a GCF? Well, it looks like we can take out a 9. So you have to do that, and then you'd be left with x squared minus 4. Then you have to recognize, wait, this looks like a difference of squares. Right? So how do we get x squared? Well, that looks like x to the second power. How do we get 4? That's 2 squared, or 2 to the second power. So when we factor this, it's going to be x plus 2 and x minus 2. And don't forget your GCF, which is 9. Alright, so this is the problem factored out completely. Okay? Let's try another one real quick. Let's say we have 18x squared minus 8. Alright, look for a GCF. Well, it looks like what we can take out from here. So we can take out 2. That will leave us with 9x squared minus 4. Okay? Then you have to check to see if this is a difference of squares. There are two terms. It's a minus sign. Are these perfect squares? Well, looks like 3x squared will give us 9x squared. And it looks like 2 squared will give us 4. So set up your parentheses. You're going to have a plus and a minus. Take these, plug them in. So it'll be a 3x plus 2 and a 3x minus 2. And don't forget your GCF. Alright. Put it in front of the factors. Then you're all set. Right? You factored the problem completely. And if you want to know if you did it correctly, alright, just FOIL these factors, alright, and then whatever you get, multiply it by 2, and it should give you this right here.